In the vast realm of the cosmos, nothing baffles and enthralls the human mind more than the mysteries of quantum physics. This realm, smaller than an atom, is a place where the laws of nature as we know them crumble. Particles can exist in two places at once, pop in and out of existence, and even affect each other's behavior from light years apart. Unpredictable, strange, yet fundamentally integral to our universe. And at the heart of this quantum enigma lies a simple yet profound experiment, the double-slit experiment. Our journey begins in the early 19th century, a time when the world of science was dominated by classical physics. The universe, back then, was a gigantic clockwork, its intricate gears and cogs ticking away in perfect harmony. In the midst of this clockwork universe, emerged a man named Thomas Young. Young was a polymath, a man of many talents and interests, but it's his work in physics, specifically with light, that would leave an indelible mark on science. Back in those days, light was a mystery. Some believed it to be made of particles, while others argued it was a wave. Young, however, had a different idea. He proposed a simple yet ingenious experiment, the double-slit experiment. Imagine shining light through two slits onto a screen. If light were particles, you'd expect to see two bright lines on the screen. If it were a wave, however, it would create an interference pattern of many lines. Young conducted his experiment, and behold, the screen showed an interference pattern. This was a groundbreaking discovery. Light wasn't just particles, it was also waves. This duality, as strange as it was, became a cornerstone of a new branch of physics that was just around the corner. And so the stage was set for a revolution in our understanding of the universe, one that would challenge the very foundations of physics. Enter the double-slit experiment, a simple setup with monumental implications. Picture this: you've got a barrier with two slits, and behind it, a detection screen. You send a beam of light, or particles like electrons or photons, towards the slits. What do you expect to see on the screen? Two bright bands of light right behind the slits, right? Well, not quite. Instead, what you observe is an interference pattern, a series of alternating bright and dark bands, as if the light or particles behaved like waves, interfering with each other. This wave-like behavior is pretty straightforward to understand if we're dealing with light, which we've long known has wave properties. But it gets downright weird when we're dealing with particles. What if we slow things down, send particles through one at a time? Surely they must go through one slit or the other, and we should see two bands on the screen, right? Wrong again. Even when particles are sent through one at a time, over time, they still create an interference pattern. It's as if each particle is somehow interfering with itself, going through both slits at the same time. But wait, there's more. If we try to peek to determine which slit the particle actually goes through, the interference pattern disappears. The particle suddenly behaves like, well, a particle, and we see two bands on the screen again. This is known as the observer effect, adding another layer of mystery to the experiment. This phenomenon, where particles seem to be in multiple places at the same time until we observe them, is called superposition. It's one of the cornerstones of quantum mechanics, and it's mind-bogglingly strange, defying our everyday intuition about how the world works. The double-slit experiment, with its surprising results, shook the scientific world, paving the way for the birth of quantum physics. And it still continues to challenge our understanding of reality, leading us to question, in the quantum world, is anything certain? The double-slit experiment, in its sublime simplicity, forced us to rethink our understanding of reality. Its results were a direct challenge to the classical view of physics, a view deeply rooted in certainty and predictability. Here was an experiment showing that particles could behave both as particles and waves, challenging our very understanding of these basic concepts. This wasn't just a minor hiccup, this was a paradigm shift. The world of physics was rattled, and out of this confusion, quantum physics was born. It was a science that accepted and even embraced the strange, the counterintuitive, and the downright bizarre. It showed us that at the quantum level, reality is not what it seems. Quantum physics took the mystery of the double-slit experiment and ran with it, opening up a whole new world of possibilities. And so, in the shadow of the double-slit experiment, a new science was born, forever changing our perception of the universe, the extraordinary world of quantum physics.